Alright, this is our video for section 5.6 part 1 on rationalizing the denominator. Now, rationalizing the denominator is the hardest part of this first part of 5.6 part 1. The reason is it combines the ideas of simplifying radicals and multiplying radicals together. So you have to combine both of those tasks and put them together into this. Now, when you rationalize the denominator, there's two cases where we would have to rationalize. You cannot have fractions under a radical sign. That's a no-no in terms of math. So if you have that, that's a case where you'd have to rationalize the denominator. The other one is no radicals in the denominator. Your denominator has to be a whole number, okay? It cannot be a decimal, and a square root, when you put it in the calculator, is going to give you a decimal most of the time. So you have to simplify that. You have to get rid of it so that it's not there anymore, and that's a case where we would have to rationalize the denominator. Alright, now I'm going to talk you through the steps as we do these examples. You've done this before. You do this in geometry, so you've seen this idea before. You probably haven't seen it with variables, though. So pay attention. We're going to change the index too. Pay attention to the steps, especially in the first example, because in the second one it's going to change a little bit. Now, you want to first decide whether it's case number 1 where there's fractions under the radical or case number 2 where there's radicals in the denominator. If it's the fraction under a radical sign, the first thing you want to do is split it up. So in example 1 here, we have the square root of y to the 8th over x to the 7th. That's a fraction under the radical sign. So what we want to do, this is still equal, so I'm going to put a lot of equal signs in our problem because it's just changing form. We're going to make it the square root of y to the 8th over the square root of x to the 7th. All we've done is we split it up now where there's a radical in the numerator and a radical in the denominator. That changes the form of the problem. It's still equivalent to what we had before. We've just changed the way that it looks. Now we have another problem. Now we have a radical in the denominator. So we have to continue to solve this. What we want to do is simplify the top and the bottom. Okay, we want to break them down. So both of them are variables with exponents. So we would do 8 divided by 2 gives us 4 remainder 0. That means that all of the y's are going to come out from under the radical in the numerator. It's just going to be y to the 4th. There's no radical left. In the denominator, 7 divided by 2 is 3 remainder 1. So we would have x cubed along with 1x that stayed underneath. Now we have a radical in the denominator still. We still have square root of x, so we have to get rid of that. And what we're going to do is we're going to choose a well-chosen 1. And we're going to multiply the numerator and the denominator by something in order to get rid of the radical. To get rid of the radical, we're going to multiply the top and bottom by whatever the radical is in the denominator, so square root of x. In the numerator, when we multiply these together, we get y to the 4th times the square root of x over, in our denominator, we get x cubed times the square root of x squared. What happens now is that radical is going to cancel itself out. The square root of x squared is really x, because 2 divided by 2 is 1. So now we have x cubed x in our denominator. Our numerator stayed, y to the 4th times the square root of x. We're going to simplify this one more step, y to the 4th square root x over, there's really 4 x's in our denominator. And now there's the answer to the problem. The reason we get to that answer and the reason that answer is okay is that now there's no longer a radical in the denominator. It's shifted to the numerator. It's fine when it's in the numerator, it just cannot be in the denominator. So again, our steps working through this, it was a fraction under the radical, so we split it up, radical in the numerator, radical in the denominator, simplified them, multiplied by a well-chosen 1, simplified again, and then we came to our answer. When you get to your answer, just double check and make sure that there's no more radical in the denominator. We're going to do another example. This one's a little different. The reason it's different is that the index is a 3. It doesn't change much in terms of the problems, but it changes what we multiply by. So let's go through this one. We've got the cube root of 2 over 9x over 9x. First thing we want to do, it's a fraction under the radicals. We want to split it up. The cube root of 2 over the cube root of 9x. Now we want to simplify them. Well, 2 is not a perfect square. It's not going to break down. In our denominator, we have 3 in x. Now, I want to pay attention to what I broke that down to, okay? Because it's not going to break down. I can't take anything out. It didn't simplify at all. But it will tell me what to do when I need to multiply by my well-chosen 1. If I think about my well-chosen 1, I want to cancel out that radical, which means I have 2 3's already. That means I need one more 3. And then I'd have 3 3's in our denominator, and they'd come out from underneath the radical sign. I already have 1x, so I would need 2 more to make my group. So I need another 3 and 2 more x's. That's what I would need to multiply by to get rid of my radical sign. So that's going to be my well-chosen 1, and that's where it differs from when I have the square root. When I had the square root, I just take the radical I have in the denominator and multiply by it. That'll cancel the radical out. When I have an index other than 2, I have to think about what my well-chosen 1 needs to be in order to cancel my group. Okay? This will cancel the radical, because now I have 2 different things, 3's and x's, and both of them there's 3 in each, so then the radical will cancel. Now I need to multiply the top and bottom by that, the numerator and the denominator. We're going to multiply across. It's important to also remember to keep your index written in your problem throughout. If you forget it, really you can't do it because you've changed the index. So I will be checking to make sure that you have your index written throughout the whole problem. In our numerator, we have the cube root of 2 times the cube root of 3x squared. There's nothing out in front of each one, so we're just going to multiply what's underneath. 2 times 3 is 6, and then x squared. In our denominator, we end up getting 9 times 3 is 27, which is a perfect square, and then 3x is x cubed. Now that what's going to happen in our denominator, that perfect cube, 27 is going to become 3, and the x cubed is going to become x. In our numerator, we have 6x squared. Numerator won't break down. 6 is not a perfect square, and x has a x has an exponent that is less than the index, so it's going to stay underneath also. So here's the answer to the problem. Okay? The cube root of 6x squared divided by 3x. Now I realize that that's a little confusing. That may be a new idea to you. Even though you've seen the top part before, throwing variables in there confuses people sometimes. So I want you to, if you have questions, to rewatch the video. Make sure you understand what's going on, and then come to class with any questions you may have about what went on in this particular video. Okay?